Hello, welcome to the one of the comparison or the improvisation of the text classification process. So we have seen that in our text classification we have used pre-trained glow word embedding. Also we have built our own word embedding, that is word to vec, and we could able to achieve the accuracy to the highest of 0.97. So in this session I am going to use a recurring neural network in order to build the same text classification model, and we will check out how it is better, or how it is more improvised versions of usage of these word embeddings, rather just is it better to use that word embeddings, or we can just go with the recurring neural network approach, everything. So we'll just first import the necessary modules required for the building of a recurring neural network for the text classification. So these are all the pre-processing or the modules which are necessary for building a recurring neural network model. So I am going to use this basically Keras as a core model or a core backend to build the recurring neural network. So from the Keras layer I have imported this LSTM, activation and dropout functions, inputs, embeddings, etc. So I'm going to build this based on the LSTM approach. So first of all I'm going to import another data set, that is spam CSV file. So it is basically a CSV file consisting of a label with spam and ham associated with each and every sentences. So I'm going to use that as a data, input data. Now I am separating it out into X and Y, because the X should be containing of only the sentences, whereas the Y or the target variable would be the label. So for that, what I am going to do, I am going to split the data in respective formats. Next I am going to convert that textual data into numerical value. So for two different labels, that is spam and ham, I am going to use this label encoder. So what this label encoder will do, it will just assign 0 and 1 for spam and ham respectively. So once that is done, I am going to use that for the further steps. Here I am splitting the entire the entire data into training and test data. So for that, what I am going to use this train test split, which is widely used and it is available in the sklearn model.selection. So I am going to call that function, and I am going to pass this X and Y data, and I am going to set this splitting value as a 0.15. That indicates that the training data will be the testing data will be 15%, and rest of the data will be used as a training. So here you could see the X train dot shape is around 4736. So we have to do certain activities in order to convert our sentences into vectors, right, or the numerical value. So here we have just converted those labels or the spam and ham labels into zeros and ones. This is done for the label part, but what about the sentences? We have to perform certain pre-processing steps to convert that sentences into numerical values, right? So for that, what I am going to use is the tokenizer, the very first thing. So I am going to tokenize the sentences into individual words, and this is the step what I am going to do first. And then once that is done, the sentences are split into individual token. Then now I am going to convert those sentences into a matrix. For that, what I am going to use sequence.pad sequence, and which I am going to pass this sequences or the textual tokens, and I am going to convert the individual text tokens into a matrix. So this is how it will be looking like. The very first row in the matrix indicates the very first sentence, and that sentence is converted into a numerical value. And how it is done? It is done using this module over here, this token text to sequences. So this is the function which is present in the tokenizer. So where does this tokenizer come from? I have used this keras.preprocessing.text where this tokenizer is available. So this tokenizer have a inbuilt function to convert those text into numerical values. So that's why I have used that. So token.text to sequences, it will basically convert that textual data into numerical values. So our input data is now completely ready. That is, the labels are converted into zeros and ones, and the sentences are converted into matrices or the numerical data now. Now we will jump into building our recurring neural network. So as a general skeleton of a recurring neural network, it will be consisting of a input layer. It will be consisting of certain number of hidden layers, and it will be finally consisting of a output layer or a activation layer or the output layer or softmax function at the end of it. So it will be generally consisting of 3 layers. One is input, middle one is the hidden layers, and last one is the output. So the input and output layer should be of single layers. These should be single layers, whereas we can alter the major hyper tuning parameters is the hidden layers. So we can alter the number of neurons, number of layers between this input and output. So these hidden layers plays a major factor while building a recurring neural network. So as I mentioned, first task is to set the input layer. So I have set that. Then I am going to set the further layers, that is hidden layers. For that I am going to use this LSTM. So the very first thing I am going to use is LSTM of 64 neurons. Then I am going to use another dense layer of 256 neurons. Then I have included one of the activation function in between, that is ReLU. We have 2 different activation functions, that is sigmoid and a ReLU. So we can use it anywhere, anytime, but as a general simple structure I have maintained this as a ReLU. Then I am going to use one of the hyper tuning factor, that is dropout. What this dropout generally will do, it will remove certain unused or the non-relevant non-relevant hidden layer neurons. So by this time it would have already occurred with 256 plus 64, right? So it would reduce out to 50% of it. Okay, so it will drop out certain neurons within the hidden layers randomly in order to minimize the number of training factors. Then I am going to use another dense layer, and finally a output layer over here. So all this done. Now our model is ready. So I have initialized the model with this parameters, that is model equals to model of inputs equals to inputs, and outputs equals to these individual layers. So this is the output layer. So as I mentioned, it should be singular. So only one output layer and only one input layer. So that is done with all these hidden layers. Now our RNN is ready. Let's have a look of the summary of a number of training parameters or trainable parameters available within this RNN which we have just built. So for that, what we can do, we can just call our inbuilt method called summary. Model.summary will yield the total number of training parameters available in the neural network which we have just built. So these are all the total training parameters which we have occurred. So finally the recurring neural network will train these many number of features in order to perform the text classification. So I mentioned this dropout will reduce the number of neurons, right? So here you could see it was around 16,640 neurons present in it. So but now at the end you can already see that the output layer is already consisting of only 256 neurons. So by this we are reducing the number of trainable parameters at the whole. So now we have ready with our recurring neural network model. Now it's time to initialize the training of it. So I am going to call this model.fit, and I am going to pass the these many number of parameters. So I will explain each and every one now. So I am going to pass this input data, that is sequence matrix, and another one is the label associated with this. So that is y train. then I'm going to pass this data in the form of batches. That is, I'm going to pass this into form of batches, 128 batches. Then I'm going to perform this training operation in 10 iterations. Then I'm going to also include validation accuracies. So that is 0.2 will be the validation split. Then finally I'm going to use one of the like monitoring aspects of Keras. That is, you can see over here in the initial import section. So Keras.callbacks. So we have different types of callbacks. We can refer to the Keras website, which are all the callbacks available. But I am going to use this early stopping callbacks from the Keras in order to perform a quicker training operation. So I have used that early stopping, and for early stopping I have to pass a value which has to be monitored. So I'm going to pass this validation loss as a monitoring feature for this early stopping. What it will do, definitely it will monitor this validation loss parameter. Whenever there is no change, or whenever there is a highest value of this validation loss has occurred, then it will stop the training process. So here you could see it has stopped at the very 5th iteration, because it has seen that the validation loss has almost reduced and it is not changing anymore, right? So it is 0.4 here and it is already 0.4 over here. So comparing these two iterations, it has stopped the training at the 5th step, and we can see that the accuracy which we have achieved by this recurring neural network is 0.99. So it is one of the highest accuracies, right? When compared to our word embeddings, it is already outreached, or it has overwhelmed all those parameters or all those techniques, and it has achieved a highest accuracy of 0.99. So by this we can see that we can use any of the techniques. Either we can use the word embeddings, that is word to vec or the glow, or we can use this traditional recurring neural network based approach based on our cruciality or the criticality of our requirement. So suppose if we are available with the time, available with the resources, then we can directly use this recurring neural network, but it requires certain cloud space, etc. and all. But whereas the word embedding approach won't require much machine parameters or the machine requirements in order to perform the textual classification. So we can jump into any of these techniques based on the availability of the resources. That's what the major criteria is. Suppose we have a well-built cloud structure, cloud architecture, everything is ready with us, then we can use this recurring neural network approach. If we have a minimum resource, that is we have a general only the limited resource of machines, everything, we can go for that word embeddings, because the word embeddings also given the very good accuracy values, that is 0.97, then we can directly use that for the text classification. Thank you.